All right, so this is the accuracy in measurements video. Uh, First thing we have to do is go over a few definitions. So the first definition we're going to look at is the accepted value. The accepted value is the standard value of a measurement. So it's what you should get. It's the correct answer. If you were to look it up in the back of the book or wherever the answers are, this is the number you would find. Okay, that's the accepted value. The second word we've got to define is accuracy. Okay, accuracy. It's the measure of the closeness of the measure to the accepted value. So of the measurement to the accepted value. Okay, and that's accuracy. How close to the right answer did you get? Let's move down just a touch and go through precision. Okay, precision is a measure of reproducibility. Okay, so it is a measure of reproducibility. Oh, forgot the C. Okay. Measure of reproducibility of a value. So when you get a value, when you get an answer, can you do it again and get the same answer? Okay, so if I measure something and I get 15, and then I measure something again and I get 25, that is not very good precision. Okay, and then the last one is error. Okay, error, that's the difference between the accepted value and the experimental value. Okay, so the difference between the accepted value, what the right answer should be, and what you actually got. All right, so the difference between these, the difference between accuracy and precision. Everybody has probably seen this example. We're going to use it again. Okay, we've got 3 bullseyes here. Okay, and then the first one, we're going to use little red dots. The first one, you know, you're just now starting out with your bow and arrow, and you hit one here, you hit one there, one right there, and one right there. Okay, you start practicing for a few more weeks, and you get to the point where you can get them all in a cluster, but they're not exactly where they should be. And then finally, you continue to practice, and you get 4 arrows right there in the middle, pretty close together. Okay, so which one of these has accuracy? Which one of these has precision? Which one has both? Which one has none? Okay, so this first one, you just started out, because they are not anywhere near the correct answer. You know, right here in this bullseye is where they should be. Okay, they are not accurate. Okay, so this is not accurate. Okay, and I think that's pretty easy for everybody to see. Because they're not in a cluster, because they are all over the place. There's one here, there's one here, there's one here, there's one here. You know, they're not anywhere near each other. They are also not precise. So this is neither precise nor is it accurate. If we move over to this second one, you know, our accepted value, or where it should be, is the bullseye again. Okay, but they're not near the bullseye, so this is not accurate. And however, they are clustered together. They're all in this small area right here. So this is precise. Okay, you have a good amount of precision, but you have poor accuracy. And then the final one, all right, again, our accepted value is this area right here, this bullseye. And because they are close to the bullseye, this is accurate. Okay? And because they are in a small area together, they are also precise. So this last one is both accurate and precise. Okay? So how do we increase accuracy in numbers? All right? Accuracy increases with more decimals, with more decimal places, I should say. Okay, so if we have 4, 4.3, 4.28, 4.276, 4.2763, okay, accuracy increases as we go down the list here. As we get more decimal places, you know, this number right here is going to be way more accurate than just 4. Okay, so 4.27363 is going to give you a way more accurate answer than just 4. All of these could be rounded to 4, but this one down here is going to be your most accurate number. Okay, so what about accuracy in liquid measurements? Okay, how do you read something like a graduated cylinder? Okay, so we have accuracy liquids. Okay, so if this is our graduated cylinder here, okay, and right, all right, good enough. So we have, those are our little tick marks, and we have something right there. Okay, we have some sort of liquid. We'll color it blue. Okay, we have some sort of liquid in there. All right, and let's say that each one of these marks is 1 milliliter. Okay. The first thing you're going to do is put this on a flat surface. Okay, so like a table or a desk or something like that, but you know that's flat, that's stable. The second thing you're going to do is get down on its level with your eye. So your eye, okay, your eye, let's say that's an eyeball. You want to be looking directly at it. You don't want to look at it from up here, and you don't want to look at it from down there. You want to be looking straight at it. Okay, so get your body and your eyes down to the table. That's why I like to use high tables, because I don't have to get down so far. And then the last thing you're going to do, you're going to look at the bottom of the meniscus. Bottom of the meniscus. The meniscus is this point right here. Okay? The bottom of it. You want to read right there. Do not read right there. All right, read the bottom. All right, so this is somewhere between 4 and 5. All right, and then just as an added step for any measurement, you are going to always estimate 1 decimal place beyond what you know. Okay, so we know that it's at least 4. Okay, we know it's at least 4. So it could be, you know, you just have to estimate. It comes over to right there. So it's not going to be 4.8. It's not going to be 4.9. So you're going to estimate somewhere that makes sense. So I would say 4.1, 4.2, 4.3. All of those would be acceptable. Okay, so anywhere from 4.1, it's obviously not 4.0 because it's not on the line. So 4.1 to 4.3 milliliters would be an acceptable range as far as an answer goes. Okay. Now this is important because you're going to use that in every measurement, whether it's a ruler or a balance or a graduated cylinder. You're going to use that every time you use a measurement or you measure something. You're always going to estimate 1 decimal place past what you actually know. Okay. Last thing we're going to talk about is inaccuracy in measurements. Why are measurements inaccurate? And there's 2 reasons. Okay? 2 reasons. And the first is that the last digit is always estimated. We just said that. Okay, we just said right up there, you're always going to estimate 1 place beyond what you actually know. So the last digit is always an estimate. So there's one reason why measurements are inherently inaccurate. Okay, the second is that measurement devices are flawed. There is no perfect measurement device. Things have to be calibrated. If it's more of a high-tech type thing, even rulers could be messed up during manufacturing. So measurement devices are flawed. Okay? That is accuracy in measurement, how to measure, and inaccuracy in measurement.